and then we'll go ahead and talk about this last method. Hopefully we will. We might get done a little bit early. Okay, so we've been talking about voting methods, and the last voting method that we're going to talk about, well, the last two, that should say Copeland method. I always say just one of these days I will give you a handout that has no mistakes in it, but don't hold your breath for that. So the Copeland method of voting, the approval method, and then a summary of the fairness criteria. And we're actually going to talk about a theorem or some result that a mathematician in the 1940s discovered about the fairness criteria. So the Copeland method, and this is sometimes called the pairwise comparison method, it's another system used for voting. It was invented by Ramon Lull, a mathematician from the Kingdom of Majorca, which is now in Spain, in 1299. And it's described in his treatise, Ars Electionis, I guess, I don't know. But for some reason, and this has happened a couple times, I guess, with voting, for some reason it's named after A.H. Copeland, who used that as well. And I think what happened is probably not a lot of people knew about it, knew about this voting method. A.H. Copeland was the first one to use it, to suggest its use on a wider scale. So they named this the Copeland's method. But then they found or discovered that it was actually invented by Ramon Lull. But since they already had called it the Copeland's method, they didn't want to call it Lull's method, I guess. And that's the way things happen a lot in mathematics. In fact, okay. In fact, like if you think calculus, Leibniz and Newton both came up with calculus independently of each other, with the methods we use in calculus independently of each other. But anyway, so that's neither here nor there. So when using the Copeland method, what do you do? Well, this one is going to require a preference ballot. So voters are going to rank their candidates instead of just voting for one of them. So just like with basically every other voting method, you need a preference ballot. Each candidate is paired with every other candidate in a one-to-one comparison. So if you have several candidates, you're going to take them two at a time, and you're going to count the number of voters who prefer. So if A and B are candidates, so I'm comparing A and B now. So what we're going to do is we're going to count the number of voters who preferred A to B and the number of voters who preferred B to A, compare those, and whichever candidate has the most votes in that comparison, that candidate will receive a point. If there is a tie, each candidate receives 1/2 point. When all comparisons have been made, the candidate with the most points is the winner. So with Copeland's method, and you have this as well. You can jot down some notes, but if you are missing anything, this is on My Open Math as well. So you have this sheet. So with Copeland's method, the candidate who can beat the most other candidates in a head-to-head comparison is the winner. All right, so Copeland's method is basically we're taking each candidate, comparing it to every other candidate, and the person who wins the most points that way is declared the winner. This should remind you of fairness criteria a little bit. If you remember the Marquis de Condorcet, and do you remember that when we use the plurality method, sometimes the person who gets the most votes does not, when you compare them, the candidates one-on-one, that person in fact does not beat every other candidate. And so the Marquis de Condorcet figured that out. And so we always say the Condorcet candidate is the candidate who wins based on comparing the candidates one-on-one. So this Copeland's method was a method that was developed in order to always meet or always satisfy the Condorcet fairness criterion. So this is something that will never, the Copeland's method will never, ever violate the Condorcet comparison, or fairness criteria, sorry. But we call that a Condorcet comparison. Anyway, so this method is helpful for making decisions involving fairly complicated criteria. It allows comparison between every option available to play a role in the decision-making process. And it's often used to elect leaders in organizations, to assess risk about a certain decision, or even to select the most qualified candidate for a job. So I do that every single time. So when using the Copeland method, it might be a good idea to see how many comparisons you have to make. Because if you have something like, if you're voting on something like 8 candidates, you'll have to compare each candidate to every other candidate. So that's a lot of comparisons. So if given the number of candidates, you may choose to use the Copeland method or not based on how many comparisons that you need to make. And there's a formula. If I have n candidates, then this formula, n times n minus 1 over 2, tells me how many comparisons I'll have to make. So let's say if there are 10 candidates, right? Then I need 10 times 10 minus 1 over 2 comparisons. Well, what's 10 minus 1?
10 minus 1.
Yeah. 9, right? So 10, and what's 10 times 9?
10 times 9?
Yeah. Just 90, right? Yeah. Yeah, so 10 times 9 is 90, so 90 divided by 2 is 45. So if I have 10 candidates that I have to choose between, I may not want to use the Copeland method because I'm going to have to make 5 comparisons. And that's a lot of comparisons to make. Unless I have like a committee or something working on this, I may not want to make 45 comparisons. So if n is equal to 10, then there are 45 comparisons to make in this case. All right, so let's take a look at a situation that asks us to use the Copeland method. And this is totally made up. This really didn't happen. Well, I don't know. It may have happened. I got this out of a textbook. So let's say in order to decide which new item to add to its menu, the restaurant chain Taco Bell did a market survey in which customers were asked to rank their preference for tacos, nachos, and burritos. The chain then used the Copeland method to determine which type of item to add to its menu. The preference schedule for the survey result is given below. So tacos is T, nachos is N, and burritos is represented by B. So if you remember the preference schedule tells us how many voters chose a certain ranking. So these voters, 2,108 voters chose tacos first, nachos second, and burritos last. 864 voters chose tacos first, burritos second, and nachos last, and so on, right? So this is telling us how many voters had each comparison. Now, since there are 3 comparisons, if you remember, since there are 3 candidates, I'm sorry, we can rank those in 3 factorial different ways. Do you remember that? We talked about factorial before. So there could be 3 times 2 times 1 ways to rank these 3 items. And 3 times 2 is 6, 6 times 1 is 6. So there are 6 ways to rank these items. Sometimes your preference schedule will not show all 6 ways. In this case, 1, 2, 3, 4, 5, 6, it does. So these are the only ways these items could be ranked. We couldn't have a 7th one out here that's a different order because all the orders are taken care of here. That's just a little bit of review. So because there are 3 candidates, though, we need to make how many comparisons? Well, let's use our formula from before. Remember, our formula is n times n minus 1 over 2. So that's going to be 3 times 3 minus 1 over 2. 3 minus 1 is 2, right? Yeah. So basically, I could say 3 times 2 is 6 and divide that by 2, but I could also just get rid of these 2's because anything in the numerator and denominator can cancel out. And I'm going to have to make 3 comparisons. So that's not too bad. So I'll use the Copeland method because all I need to do is make 3 comparisons. So with the Copeland method, what we need to do is we need to compare tacos to burritos, let's say, or nachos. So we need to compare tacos versus nachos. We need to compare tacos versus burritos. So that's tacos compared to both of those. Now we need to compare nachos versus tacos, but guess what? We already have that in this comparison, right? We need to compare nachos versus burritos. We don't have that listed yet, so nachos versus burritos. And since I have 3 comparisons and I knew I had to make 3, I can stop there. These are all the comparisons I need to make. Because if I think about burritos versus nachos, I've already got it. If I think about burritos versus tacos, I've already got it. So I only need to make 3 comparisons here. Okay? Does that make sense? Is that okay? It's not too bad? All right, excellent. So I'm going to scroll up I'm going to leave my rankings here, but I'm going to scroll up so I have more space. I need that first choice. Okay, so what I want to look for when I'm comparing tacos and nachos is I want to give that number of voters to tacos in every column where tacos is above nachos. So here in the first column, tacos is above nachos, so I'm going to give tacos in this comparison 2,108 votes. Here, tacos is above nachos, so I'm going to give tacos the 864 votes. Here, however, nachos is above tacos, so nachos gets these votes. This really isn't difficult. It's a little tedious, though. Yeah. Let's see, where are we at now? Here, again, nachos is above tacos, so nachos is going to get the 1461 votes. Tacos is above nachos in this case, so tacos gets the 1587 votes. If anyone is, I don't think anyone's logged in, but if anyone from Lee County, they're probably thinking, I finally learned how to write, because usually I'm trying to write with the mouse and I make anyway, it's terrible. And then the last one is what we have to compare. Nachos is above tacos again here, so nachos gets the 1080 votes. And now all I have to do is add these up, and I've already added these up for us. I think that tacos, unless I've made a mistake, which could happen, tacos ends up getting 4,558. I'm just going to check this. Let's see. Oh, okay. Excuse me. I'm sorry. 4,558 votes, and nachos gets 3,697 votes, so 3,697. So in this case, tacos wins that comparison, right? So we're going to give tacos, or T, gets 1 point. Now, let's make another comparison. Tacos versus burritos. All right, so here, any time that we see tacos ranked before burritos, we're going to give those points to tacos. Anytime we see burritos ranked before tacos, we're going to give those points to burritos. So tacos is above burritos here, so tacos gets 2108. Tacos is above burritos here, so tacos gets 864. Tacos is above burritos there. Tacos gets 1156. And then in the last three, burritos is above tacos in each one of those. So burritos gets 1461, 1587, and 1080. So when you add these up, which I've done this already, tacos ends up getting 4,128 votes, and believe it or not, burritos ends up getting 4,128 votes. So that's a tie, right? So if there's a tie, remember each choice gets half a point. So I'm going to give tacos 1/2 of a point, and I'm going to give burritos 1/2 of a point. And now let's do the last comparison. So anytime that nachos is above burritos, we're going to give nachos those points. So nachos is above burritos here. So they get the 2,108 points. Nachos is above burritos here, so they get the 1156. And nachos is above burritos here, so nachos gets 1461. So 2108, 1156, and 1461. So when I add that up, that's going to be, I think, 4725. And then burritos gets the other points. Burritos gets 864, 1587, and 1080 for 3531. So in this case, nachos wins out. So nachos gets the point. So nachos gets 1 point. All right, so now let's look at the points. I've got tacos, nachos, and burritos. Tacos gets 1.5 points. So tacos gets 1.5 points. Nachos gets just 1 point. And burritos gets just 0.5 point. So which one is the winner in this case?
Tacos.
Tacos, right? Tacos has the most points. So using Copeland's method, we say tacos is the winner, so the new menu item will most likely be a kind of taco. So tacos is the winner. So that's not really difficult, but it is kind of like, why would you use Copeland's method, I guess. And mostly this one, the tediousness comes from the fact that there are all these numbers that we have to add up. Let's look at the next example that I have, and in this next example, it's not as bad because we don't have as many votes. So I'm going to go over to the next example. Okay, so let's consider this situation. So HCTC Scholarship Committee will award the Excellence in Mathematics Scholarship. We don't have such a scholarship. I just made that up. To a student who is transferring from HCTC to Morehead State University. There are 4 students eligible for this scholarship: Anastasia, Dimitri, Boris, and Catherine. We don't have any students named that either. Those either, so I messed up. Maybe Catherine, but the committee members have ranked the candidates for the scholarship and will use the Copeland method to choose the winner. The preference schedule is provided below. So there are 4 choices this time. There are 4 candidates. So how many comparisons have to be made? Well, 4 times 4 minus 1 over 2. What's 4 minus 1? 3. So 4 times 3 over 2, that's 12 over 2, or 6. So we have to make 6 comparisons in this case. Okay? So how many people voted in this election? Well, if we add the total votes row, we'll get the number of people who voted. So 5, 5, 6, and 4, that's what? 20, right? So there are 20 votes. So that's not too bad. 20 votes total. So there were 20 people on this committee. So what are the comparisons we have to make? I know I have to make 6 of them. I have to compare Dimitri to Anastasia. I have to compare Dimitri to Boris. I have to compare Dimitri to Catherine. Okay, I have to compare Anastasia to, something's going on here. It doesn't like me in that space. I have to compare Anastasia to Dimitri, but I've already done that here. I have to compare Anastasia to Boris. I have to compare Anastasia to Catherine. And then I have to compare Catherine to Dimitri. I've already done it. I have to compare Catherine to Boris. I don't have that yet. So Catherine versus Boris. And that's it, because I have 6. 1, 2, 3, 4, 5, 6. So I know I've made every comparison. I don't have to even check the other ones. Okay? So that's the reason why we like to know the number of comparisons. So here I have to make 6. All right, so let's take a look. Dimitri, I might, since these are close together, use a different color. So let's compare Dimitri to Anastasia. So everywhere, every column that Dimitri is higher than Anastasia, that Dimitri gets those points. Uh-oh. So Dimitri is higher than Anastasia here, so Dimitri gets 5 points. Dimitri is not higher than Anastasia there, so Anastasia gets those 5 points. Right? All right, so let's see. Dimitri is higher than Anastasia here, so Dimitri gets these 6 points. And Dimitri is higher than Anastasia there, so Dimitri gets these 4 points. So Anastasia only gets 5 points. Dimitri gets 15 in this case. So who wins the point here? Dimitri. So Dimitri gets a point. Good. All right, what about Dimitri versus Boris? So Dimitri gets these 5 points. Boris gets these 5. Boris gets these 5, right? Or sorry. And then Boris also gets these 4. So in this case, Dimitri has 5 and Boris has 15. So Boris gets this point. So 1 point for Boris. Okay, now let's look at Dimitri versus Catherine. Dimitri is above Catherine here, so he gets 5 points. Catherine is above Dimitri, so she gets 5 points. Catherine is above Dimitri, so she gets 6 points. And Dimitri is above Catherine, so he gets 4 points. So Dimitri gets 9 in this case, and Catherine gets 11. So Catherine ultimately gets this point because she beat Dimitri by 9, 10, 11, right? All right, let's look at Anastasia and Boris. So Anastasia is above Boris here and here. So I'm going to abbreviate a little bit and say Anastasia gets 10 points, 5 and 5. But Boris is above Anastasia here and here. So Boris also gets 10 points, 6 and 4. So what does that mean about Anastasia and Boris? They get half a point each. All right, excellent. For Anastasia and Catherine now. Anastasia is above Catherine here, above Catherine here. and above Catherine here. So 5, 5, and 4. I'm going to say that's 14. And then Catherine's above Anastasia here. So Catherine gets 6. So Anastasia gets the point there. And then finally, the last comparison, Catherine and Boris. So let's see, Catherine is above Boris here, above Boris there, and above Boris there. So Catherine gets 16 points, and Boris is above Catherine here, so Boris gets 4 points, so Catherine gets the vote. So I've got Dimitri, Anastasia, Boris, and Catherine. How many points total does Dimitri get? Dimitri just has 1. Anastasia has 1.5. Boris has 1.5. And Catherine has 2, right? Excellent. So who wins? Who wins the award? Yeah, well, gosh, I had all the space. I could have written it a little bit. Yeah, so Catherine wins the scholarship. So Catherine will receive the scholarship. But wait. Oh, no. The night before the scholarship award ceremony, the committee finds out Dimitri is ineligible for the award. So Dimitri doesn't get, he's not able to get the scholarship. He didn't anyway, but since he failed Math 146 last semester, the committee members decide to be absolutely fair, they must conduct the election again. They are confident Catherine will still be declared the scholarship awardee. They're confident because taking Dimitri out shouldn't affect that Catherine won, right? You don't think it would, right? Dimitri didn't win, so.
But wouldn't it change like the order?
Yes, it is. It is going to change the order a little bit. So this is what we find. The preference schedule with Dimitri eliminated is given below. So here we have this preference schedule. And so now we must make just 3 comparisons, if you remember, since there are only 3 candidates. And it is going to change the order. You might not think it should because Dimitri didn't win anyway. So it shouldn't change the fact. But if we vote again with Dimitri eliminated, so watch what happens. So I need to compare Anastasia and Catherine. I need to compare Anastasia and Boris. And then I need to compare Boris and Catherine. Right?
Yeah.
And that's all my comparisons. We're still good, yes. All right, so Anastasia is above Catherine here, so 5. Anastasia above Catherine here, so another 5. Catherine's above Anastasia there, so Catherine gets 6. But Anastasia's above Catherine, so she gets 4. So Anastasia has 14 of the votes. Catherine has 6. So Anastasia gets that point. All right, Anastasia and Boris. Anastasia is above Boris. She gets 5. Anastasia is above Boris. She gets 5 more. Boris is above Anastasia. He gets 6. And Boris is above Anastasia. So he gets 4. So they both have 10 in this case, so they each get 1/2 point. So Anastasia gets a 1/2 point. And Boris gets 1/2 point. And now Boris and Catherine. Catherine's above Boris here, so she gets that 5. Catherine's above Boris here, so she also gets another 5. Catherine above Boris there, so she gets 6. Boris is above Catherine here, so he gets 4. So Catherine has 16. Boris has 4. So Catherine gets the point. So look what happens when we tally these points. We have Anastasia, Boris, and Catherine. Anastasia has 1.5 points, right? So 1.5. Boris has just 0.5 point, and Catherine only has 1 point. So what has happened since we've deleted or eliminated Dimitri? We've eliminated that comparison that Catherine had with Dimitri, which gave her an extra point, right? Gave her another point. So now Anastasia with 1.5 points is the winner of the scholarship. So as you might have guessed, the Copeland method violates a fairness criteria. And is everybody okay? Got this? I'm going to move on to the next slide. I think I am anyway. So once again, say what? You wouldn't think that the elimination of Dimitri would affect Catherine's status as winner of this election, but it obviously did. So this is a violation of a fairness criterion, the independence of irrelevant alternatives criterion. And since that's a mouthful to say, we usually say the IIA criterion. So the independence of irrelevant alternatives. What that says is that if a non-winning candidate is removed from the ballot, it should not change the winner of the election. So if someone wins and then a non-winning candidate is removed, totally, it should not change who wins. But obviously, it did in this case. So Copeland's method is susceptible to the IIA criterion. All right, so the last voting method we will mention is called the approval method, and the reason why we sort of talk about it on its own is because it doesn't require voters to rank the candidates. So if you have a preference ballot, you wouldn't in fact have a preference ballot for approval method. What you would do is just basically have a list of the candidates, and then the voters, they mark all candidates that they find acceptable. The results are tallied, and the candidate with the most votes is the winner. All right. So I don't know if you remember the 8 friends who were going to dinner in Lexington from the first lecture on voting. Candy, Mandy, Tandy, Brandy, Andy, Randy, Sandy, and Mandy. They all met for Lexington, and then after dinner, they decided that they wanted to see a movie. They narrowed the choices down to, this is obviously happening in the future. Maybe it's this weekend or the weekend after next, because I don't think a couple of these are out. But they narrowed the choices down to Dumbo, Captain Marvel, Pet Sematary, and Avengers Endgame. And the table below summarizes each voter's choice. So, Dumbo, Mandy, Sandy, Candy, Andy, and Vandy all said that they would be fine seeing Dumbo, right? Randy didn't want Dumbo, and neither did Brandy. Captain Marvel, we had 1, 2, 3, 4, 5 people who said Captain Marvel was okay. Pet Sematary, not as many people wanted to see Pet Sematary. And then Avengers Endgame, Sandy, Candy, Tandy, Brandy, and Vandy wanted to see that. So with the approval method, all you do is just tally up the number of votes that each movie got, and the movie with the most votes wins. So how many votes did Dumbo get? 6 votes. How many votes did Captain Marvel get? 5, right? How many votes did Pet Sematary get? 4. And Avengers Endgame? 5. So what did the friends end up seeing? Dumbo, right? Good choice, I guess. All right, so that's basically the approval method. It's the easiest method to think about. It's also, I mean, I'm not sure that we should elect officials using that method, but I mean, that method is totally appropriate for what movie should we see, because really this satisfies the majority. The majority of the people said that they wouldn't mind seeing Dumbo, right? So the only people who may be mad are Randy and Brandy, But let's say if everyone decided to see Pet Cemetery, then you have Mandy, Sandy, Tandy, and Andy. They don't want to see Pet Cemetery, so that's more people upset about that. Okay. All right. So quickly here, and I think we're going to finish up pretty quickly. I don't know if you've noticed this or not, but did you notice that every voting method we studied seemed to violate a fairness criterion? When we studied the plurality method, it violated the Condorcet criterion, right? We also had something called the monotonicity criterion, and remember that was when if a voter changes their mind and votes for the winner of the election, that shouldn't change the fact that that person is the winner, but it did in one of the ones that we looked at. There's a video as well if you don't remember that one. So we had 4 fairness criteria. The Condorcet one, the majority criterion, that's the one we talked about on Monday. The independence, the IIA, or AII, whatever it is. No, IA, sorry. And then the monotonicity. So you might be asking yourself, is there a method that will be fair, totally fair every time? Is there a voting method that is completely fair all the time? Well, in 1949, the mathematician Kenneth Arrow, and this is Kenneth Arrow, he was a mathematician and economist and social theorist, was able to answer this question and prove his answer was correct. And the answer is no. We call this result Arrow's impossibility theorem. And Arrow's impossibility theorem states that no voting system can satisfy all 4 fairness criteria in all cases. So every single voting system has the potential to violate one of the 4. Now there are some voting systems that will never violate some fairness criteria. For example, Copeland's method, where you do a head-to-head comparison, will never violate the Condorcet criterion, because the Condorcet criterion says that the winner of the election should be the person who wins in a head-to-head comparison. So, but you know, it might violate the majority. Even approval voting may violate the majority criterion as well. So it looks like we're a little bit early. Does anybody have any questions over anything that we've done? All right, when I get back to the office today, I will try to set this up. What I do is I download this video and put it on YouTube, and then I link it to the course. So I'll try to have this by the end of the day, and I'll also try to have a study guide for voting methods that we can talk about. So you can have a chance to look at that study guide over the weekend. On Monday, we'll talk a little bit about it, and then I'll probably end up changing the outline to say that you have a take-home test for this third one, and then on Wednesday of next week, we'll get started on probability. Does that sound good? All right, and if you take that test as soon as you can, and then I'll come back, I guess. I won't. Next week I'll be in Hazard both days, but the next week I'll be in Lee County on Wednesday. So after I get done with class that day, I'll run over here and get that test for you. Is that okay?
Yeah.
All right. All right, cool. I guess that's it. I'm done for today. If you don't have any other questions, I guess we can call it a day then. All right, sound good?
Yeah.
All right, so I'm going to stop recording.